In the previous lesson, we saw the block diagram of the system, but in many cases, it can be very helpful to use a diagram that is called sequence diagram. Sequence diagram is part of UML, Unified Modeling Language. This is a subject on its own, but sequence diagram you put here on the top, you put the object or the classes or the modules. So here I have two modules, task scheduler and task queue. And you can think about this vertical axis as the time axis. So it starts here and it ends here. And the sequence diagram is describing some use case. So in this use case, the queue is empty. This queue is empty. Okay? So to start the scheduler, the actor invokes the start. What we have here, this arrow is marks invoking a function, and the function belongs to what we have here. So if start is invoked on this line belongs to task scheduler. So it means that the actor invoked start of the module task scheduler. So now, after it started, the clock of the task scheduler is starting to run. In the example, it ran every 2 seconds. And every 2 seconds, he's calling internally a function that is called dispatch callback. This dispatch callback is the function of task scheduler. And this function goes to task queue and is performing the queue. The queue means that it goes to the queue and take the item which is in the head of the queue. And if the queue is empty, then it returns null. Nothing can be done. And after 2 seconds, again, nobody is enqueue anything. So the interval or the clock of the task scheduler is called dispatch callback. Dispatch callback call the queue of task queue and return with a task, but the task is null because nothing there to be found. So this is one use case, and in this use case we have only 2 modules. But what happens if the queue is not empty? So again, this is a sequence diagram, and you see here this line belongs to task scheduler, this line belongs to task queue, this line belongs to task dispatcher, and this line belongs to persist. So at the beginning the queue is empty, and then the actor calls the enqueue function of the task queue, and it passes him a task 1, maybe the add or maybe the get post. So first, what the task queue is doing, he is saving himself to the storage because there was a change. And then suppose that the actor start. If the actor start, then the scheduler will invoke the dispatch callback every interval. In the UI example, it was every 2 seconds. And what happened? We saw it before. Now we have one task in the queue. It's called task 1. So when the dispatch callback goes to task queue and call its function, the queue of the task queue, it will return the task that is in the head of the queue, which is task 1, this one. Now the dispatch callback has this task 1 and is calling the dispatch function of task dispatcher. He passes him task 1, he passes him the argument, which are maybe for add argument 1 and 2 and the function add, and he invoke the function with the argument and return the result. So if it was add 1 and 2, the result will be 3. If there is another function, maybe add with 2 and 3, it will return 5. If there is another function that calculates something, it will return the result. Okay? Now, after the task is dequeue from the queue is empty, but the scheduler continues to run because it is not stopped. So in the next time that it will go to dequeue from the queue, it will return null. So in this sequence diagram, it's easy to see the relation between the modules with respect to the time, with respect to the flow of operation.